In this video, I'll teach you how to recognize and solve permutations questions on the GMAT quantitative section, and we'll derive the formula for permutations questions with a logical connection back to the basic ordering task and formula that we learned in the last video. So let's return to our example questions about choosing and arranging cars or choosing and arranging contestants in a talent show. In this case, we have a full number of 7 in both of the examples, and a selected and arranged group of 4 elements. So we would solve each of these questions using the same exact formula. So as in the basic ordering questions, we have an n of 7 representing the entire group from which we are choosing and arranging. We also have a new variable of r. In this case, it equals 4 because that's the number of things that we want to select and arrange, 4 cars or 4 contestants. So we can return to our approach of thinking of this in terms of filling slots. But this time, we only have 4 slots to fill because we are selecting and arranging 4 things from among the full group of 7. So I've blocked out those last 3 slots that in this case don't exist. The interesting thing about permutations and combinations questions is that even though we are only going to consider 4 of the 7 elements, we will still start with the numbers of the full number of elements, because the first time you assign an element to a slot, you still have 7 choices, even though you're only going to choose 4, and then 6 choices, and then 5, and then 4. So we see the 3, 2, 1 that did exist in the basic ordering question. It's like they've been canceled out in this question, and this is going to lead us directly into the permutations formula, where we have this new piece of n minus r factorial in the denominator. What this does is effectively cancels some elements from the end of the operation so that you are left with r factors after the cancellation. If you cancel n minus r out of n factors, you are left with r factors, so that the 7 times 6 times 5 times 4 left in the numerator of this function represent the 4 numbers of possibilities every time you assign an element to a slot. So we can think of permutations as being basically like basic ordering, just with a stopping point after you have assigned the first r things.